What if our cities of tomorrow weren't lit by electricity, but by living, breathing light? Imagine towering structures bathed in the soft, ethereal glow of bioluminescence, deep beneath the ocean's surface. This isn't just science fiction, it's a look into how we could engineer nature's own light to power breathtaking underwater metropolises. Bioluminescence is nature's own magical light show, living organisms producing a glow through chemical reactions inside their bodies, often without heat or electricity. It's most famously seen in fireflies, glowing plankton, and deep-sea creatures that illuminate the darkness. The core question is, can we harness this glow for our future cities, especially underwater? The answer is yes. Scientists are actively exploring ways to harness bioluminescence for sustainable urban lighting, including concepts for underwater environments. While it's not yet ready to replace electricity on a large scale, projects using bioluminescent bacteria and algae show promising potential for eco-friendly illumination. The deep sea is home to an astonishing variety of bioluminescent organisms. Nearly 8% of known species below 200 meters can produce their own light. The glow comes from a reaction between luciferin, a light-emitting molecule, and luciferase, an enzyme, triggered by oxygen and energy molecules like ATP. This process is a type of chemiluminescence, but uniquely biological. Key groups include dinoflagellates and plankton, tiny drifters that create glowing waves and milky seas visible from space. Cnidarians, jellyfish siphonophores, use pulsating light displays to startle predators or lure prey. Crustaceans, shrimp, krill. Some eject glowing chemicals like underwater flares to distract attackers. We can translate bioluminescence into sustainable city lighting by using living organisms like bacteria, algae, or engineered plants that naturally emit light, embedding them into urban infrastructure as eco-friendly alternatives to electricity-powered lamps. Currently in France, Rambouillet. The city tested bioluminescent street lamps using microorganisms in transparent tubes, glowing softly at night. Another used plants and mushrooms. Projects explore glowing petunias and fungi as decorative, low-energy lighting for parks and walkways. Current research in synthetic biology and genetic engineering is focused on reprogramming bioluminescent systems, luciferin-luciferase reactions, into controllable, modular tools for biotechnology, medicine, and sustainable lighting. Scientists are isolating natural light-producing genes, optimizing them for new host organisms, and engineering brighter, more stable bioluminescent pathways. Bioluminescent lighting in marine environments offers major environmental benefits. It produces gentle, natural light without electricity, avoids harmful light pollution, and integrates seamlessly into ocean ecosystems. Key environmental benefits include no light pollution, energy-free illumination, eco-friendly integration, and support for biodiversity. There are also some practical applications in marine environments like underwater research stations. Soft bioluminescent lighting could allow scientists to work without disturbing marine species. Bioluminescence could transform future environments into glowing, self-sustaining ecosystems, providing soft illumination for habitats, guiding navigation in oceans, and even powering agricultural systems with natural light. As we stand at the frontier of engineering life to serve human needs, we must pause to reflect on the ethical weight of our choices. While biodesign promises sustainable cities, medical breakthroughs, and new ways of living, it also risks reducing living beings to mere tools, disrupting fragile ecosystems, and widening inequalities in access. The challenge before us is not simply scientific, it is moral. To innovate with respect for life, to safeguard animal welfare, to ensure transparency and fairness, and to balance human progress with ecological harmony. Only then can our pursuit of engineered light and life truly illuminate a responsible future. These naturally illuminated cities would not only reduce our dependence on electricity, but also reconnect us with the rhythms of the planet, reminding us that progress can be beautiful, sustainable, and alive. Yet this vision will only come to life if we choose to shape it responsibly, balancing innovation with respect for ecosystems, equity, and the sanctity of life. The question before us is not whether we can engineer light, but whether we will do so wisely, ensuring that the glow of tomorrow reflects both human ingenuity and our deepest commitment to the world we share.